Hello and welcome to the next episode of Moments with Atmos Reaper. Today we will talk about Atmos Water Harvesting AWH and how standards and verification help the technology move forward in real-world application. My name is Amin and I'm very happy to host this conversation today, and I'm joined by my colleague Shahnawaz Sinha. Shahnawaz. And today we have two excellent guests with us. Christoph Lohr, Vice President of Technical Service and Research at IAPMO, and Terry Berger, who has deep expertise in standards and certification related to AWH. Thank you both for joining us today. To start our conversation, I would like to begin with a quick introduction. Can you briefly introduce yourself and your roles related to atmospheric water harvesting?
Certainly. So my name is Christoph Lohr. I am IAPMO's Vice President of Technical Services and Research. IAPMO is an abbreviation, IAPMO, which is used to be short for the International Association of Plumbing Mechanical Officials. Actually, this year we turn 100 years old. And specifically in my role, we provide a lot of education around the work that Terry and his colleagues in codes and standards do in terms of developing the standards. And so we help provide training manuals, study guides, and other educational, such as this podcast here, where we provide education around those topics. My background has been here in Arizona for over 15 years now as a licensed professional engineer that did a lot of design. So I have deep experience and expertise in how these codes and standards get utilized by the engineering folks and construction professionals, in industry. Terry, what about you?
All right, I'm Terry Berger. I'm the Senior Director of Standards Development for IAPMO ASSC. I'm part of the Codes and Standards Development at IAPMO. Generally, what I do is, and my team is, we work on developing standards mostly related to plumbing products, and some kind of aspect of plumbing. We write national standards for both the US and Canada. My background is I'm a mechanical engineer. I've been working in the plumbing industry for over 40 years, and I've been working in codes and standards for 30. So I've been doing what I'm doing for quite a long time.
Awesome, guys. I would like to start with a broader question. Why are standards and verification important for AWH right now? Terry?
Um, sure. Well, right now, this is a new technology. It's growing, it's expanding. There's more and more players coming into the field, into the market. And with that, generally what happens in any kind of emerging technology, you get people making some outrageous claims, some good claims. There's good products, there's bad products. It's almost like the Wild Wild West when it first starts. So what standards does, it says, okay, let's have a fair playing field. Here's the minimum requirements that all these products need to meet. So that way, people can't make outrageous claims because the standard's going to verify those claims. So if you're claiming a certain efficiency, they're going to check to make sure that the standard's going to have somebody check that efficiency and make sure that you're not boasting something that you can't achieve. It also puts a minimum safety requirements on these products. I mean, a lot of them have electrical features, they're electrically powered. So you want to make sure that the right electrical standards, the right mechanical standards. And you're also looking to make sure that the life of the product is, you don't want something that's going to last 1 year. So usually there's some kind of criteria we evaluate what the durability and reliability of the product is. And so in mature markets, this is just kind of old hat. Everybody just does it and thinks about it. In new technologies, we have to actually develop the work and the standards and the requirements from scratch. So that's kind of why it's important for this industry, because it's new and it's growing.
Terry hit the nail on the head. The only thing I would add is from the industry perspective, one thing worth noting that I think comes as a bit of a surprise for many folks that are in the water industry and really kind of focus more upstream of the water meter is that codes and standards and all of that in the regulatory environment within or downstream of the water meter within the premise plumbing system, the regulations work very differently. Regulations most of the time in the water industry, people think restrictions, like, oh, I'm not allowed to use this. If I have a new regulation, I'm not allowed to use this. You have to take that entire paradigm and flip it upside down when it comes to the plumbing industry. Speaking as a licensed professional engineer, I did design for a number of years. if there wasn't a standard for a product, I likely was not going to use it. Let me repeat that for listeners. I was looking for standards and regulations and codes to address new subjects. Otherwise, I would feel it was too risky to utilize those products in my design. And similarly, many installers take the same approach. They want to see it in the codes, and many inspectors of plumbing systems take the same approach. So what Terry said is really, I mean, it hits right home and in terms of how the industry thinks about new products. They want to see a standard associated with it, A, to know that it's safe, and B, that it's going to do what it claims to do. And that's why really, plumbing standards around products that are put into the built environment, they're really the lifeblood of innovation when it comes to how we use them in within industry, within a building, or downstream of the water meter.
Well, awesome. Sounds good. Now we would like to move into how engineers and project teams think about using AWH practice. I will hand this section to Shahnawaz. Shahnawaz?
Thank you, Terry. Thank you, Amin. Thank you, Christoph. Thank you for sharing all these insights about how the standards and regulations are important for all engineers. So today I have got a few questions for you. Like the first one is like, as you know, there's a renewed interest in atmospheric water harvesting. We're still figuring it out where and how it fits into the water sector. Where do you think its future lies in serving the water sector, and what condition will determine its acceptance and feasibility in this sector?
That's a great question, a great way to start it. And just speaking from my experience, especially because it's a new technology, one of the things that we often have to look for, with engineering is it's really that confluence of science, public health and safety, and economics. You can't make the best technology and then it's gold plated that nobody can really afford it. So where I think the atmospheric water harvesting is likely going to play a role is in those areas that maybe don't have access or an easy access to water sources. And I think that's going to be a starting point. As an engineer, if I'm doing a more remote project and I don't have a groundwater well, that might be a great way to get a fresh water source for that home or for that building. But I do think that there is a shift that can occur too. A lot of my work was done in healthcare, and within healthcare, there's a lot of requirements to have redundancy of some kind, for various technologies, just to make sure that the patients aren't adversely affected. And so, you might have something as simple as a home on a remote, plot of a parcel of land, but you could also see these also may be deployed in a healthcare environment where the funding is more often there for utilization for redundant systems. And one of the very real possibilities is using atmospheric water harvesters in lieu of a large storage tank, because you're going to have a way to create fresh water in essence at your site. And so I think that's kind of the two bookends that I see as potential areas, and that's how engineers would probably think about it: is what's going to be feasible, what's going to solve the problem that I'm trying to address in the building that I'm working at right now.
That's a great insight. And as you mentioned, like engineers are working on this area. And the next question is related to the engineers. Like when engineers are evaluating atmospheric water harvesting as for a project, what are the first question they need to ask themselves, you think is important?
Well, and I think it's not just what they should ask, but I think what they will likely ask, and that's what's the standard? Is this tested to this certain product standard? Going right back to Terry. If I'm sitting there thinking about any time that I utilized a new technology with an owner, usually it came because the owner had a very specific problem that they needed solving. But if I was going to suggest a type of a solution that was a newer one, I would look to try to have ones and whittle the list down to ones that were in compliance with the standard specifically that was out there. That gave me a better feeling of putting my PE stamp on that set of construction documents. But it also gave the owner a little bit of a better feeling too, in terms of, hey, we have something that has some kind of third-party evaluation behind it. It's not a total shot in the dark, in terms of spending money on this particular product on a project.
This is great info. Terry, do you have anything to add here? I'm going to say one of the things that the standard does that would give some of the answers is, one of the things I evaluate, what is the production rate? I think that's one of the questions the engineer is going to ask is this device that I'm recommending going to produce enough water for the need that I'm trying to, solve the problem for? So that's kind of where they run in parallel. So, that is one of the standards that we've developed at IAPMO, which is for drinking water from air water generators, one of the very first requirement is determine what the production rate is. And it mandates that the product has to, in its literature and on the product itself, specify what is the rated capacity.
Yep.
Does the economics also play a role there? Like how expensive the water would be in terms of the production? That also critical, huh? You would say.
Well, our standards are performance,
Yeah.
so we don't really get into the cost associated with it. Now, if you look at, say, if I was doing a project in northern Canada
Mhm.
where water is more than abundant, the cost of this probably doesn't make sense.
Yeah.
So we have regional people that would be using the standards. Regions that are arid or don't have a good potable water source, or their water source is questionable, then they would use these types of devices. So that would all, I think, would all go into the information you need to decide what is the best solution for the problem, whether these are the devices you want to use.
Yep. Yep. And that goes back, Shanawaz,
Yeah.
to kind of what I was mentioning before. I think that there's some pretty, there's a big range. Again, if a home in a remote part doesn't have access to water, it
Mm.
becomes very, they need it. But a hospital, many healthcare facilities are required to have, 24, 48, 72-hour, storage requirements. And so they have to have very large holding tanks that also, they have to worry about supplemental disinfection too to prevent waterborne pathogen amplification. So now all of a sudden those costs multiply on these systems. What I think will be very fascinating to see over the next few years is if healthcare plumbing engineers and installers start looking at atmospheric water harvesters to replace the backup from the city with an atmospheric water harvester to serve the hospital with maybe a smaller tank that makes everything a bit on that side more feasible. So, to your point, yes, economics are definitely going to come into play, but it's one of those that some people are going to look at it depending on the type of solution they're trying to, and the type of problem they're trying to fix.
It's a great addition that you are sharing with us, like hospital. They also need a pretty clean water, and atmospheric water harvesting could be one of the solution. This is great.
Yep,
We were thinking about more like a residential, industrial, other sector, but the hospital is also very important, critical. And
definitely.
so my last question on this sector is more like this. What are the common misconceptions are there about the atmospheric water harvesting? And and do you think the standard and the standardization testing that you just mentioned can help clarify some of this misconception of the atmospheric water harvesting?
So I think, I guess, in terms of misconceptions about atmospheric water harvesting, I think, what one of the misconceptions that could come out there, and Terry, I'll probably feel free to add to this one too. Yeah, I think whenever there is that new technology, and Terry alluded to this earlier, on the engineering side, there's going to be a bit of a reluctance. So there's going to be a misconception. Is atmospheric water harvesting something that's real? Is it something that works? Is it something that I can trust? So that kind of trust factor, if you will, is one of probably the first misconceptions for any new technology. And I think atmospheric water harvesting probably falls into the same boat. And that's one of those things. If you have a standard behind it, whether it's an IAPMO ANSI standard or an IGC, which are different types of standards that we offer, and Terry can get into the nuts and bolts of it. But that helps. That helps tremendously in terms of overcoming that initial trust factor because you have had that third party. And I know we've kind of harped on that a few times here, but it really does make a difference. Speaking from my end of an experience of things. Terry, anything you want to add?
Well, I think in this particular type of product, the misconception is it's not making good water. People look at it and say, well, man, you're taking this out of the air. There's pollutants. You've got bird droppings. You've got all kinds of things that are going to contaminate your water. And so there's a little bit of an ick factor that I don't want to drink this stuff. And the truth of the matter is when these devices have means of treating and we evaluate how effective that treatment is. So it's again like some of the other technologies out there where we're recycling water from sources that people would not normally think of being a source to get water. There's that I call it the ick factor, like, ooh, I don't want to drink that. And so I think there's a little bit of that with this here too, just because we know there's all kinds of things in our air that we don't want to consume. But the standard and the devices that are on the market are addressing that.
This is a great point. So it gives you like the consumer or the customer added secureness and like in drinking this water. They think this water is meeting all the standard and it's safe for me to drink. So this is very critical to have those standards. Yeah. Okay. So I will. I think Amin would have some question about the application of this.
Yeah,
Yeah, sure. Amin, go ahead.
thank you. And now let's talk about application. AWH is being discussed in many different contexts, from building to remote location to AI ecosystem. So I would like to ask, what application are most commonly considered for AWH today? And what requirements drive those use cases? For example, water quality, operations, cost, energy. Terry?
Well, the two areas that I've seen the most interest in these devices is actually Israel and in Dubai. So in the Middle East, where water is very scarce, I've seen a lot of interest in those regions. There's a manufacturer in Israel that makes these things, specifically for like the farms and stuff. So I don't think they're using them for irrigation, but I think they're using for the residential and the consumption that they have actually in their dorms and their homes. And I believe the one that I know of in Dubai was actually using this for processed water to generate processed water for some type of manufacturing, or maybe even in the petroleum industry. I'm not sure. It was for processed water. So there's two applications and two regions where it's really critical. Another area where I've heard, but I don't have any good solid, is the Southwest. The American Southwest has also has some people look into it, but I don't know of anybody that's actually implemented it, but I'm sure there probably are. So those are the kind of regions where it's more for like residential or commercial use. So residential for like human consumption, smaller capacities. And then if you want to scale it up for like a process or commercial applications, it would be a larger unit, which would be more costly. But then, that's offset by the the production the benefits of the production. So that would have to all go into consideration.
Christoph, do you have anything to add here?
No, nothing on this question.
Okay, awesome. So now let's talk about technology and real-world performance. Shahnawaz, could you please start this section?
Oh, sure. I mean, yeah, I think that they've covered some of this items, what we want to ask about, but I will ask in a different format. Like, as we're saying that we're discussing today, that we're seeing a lot of interest in the atmospheric water harvesting, but what do you think are the real world constraints and what we need to overcome? And what are the most often mentioned challenges, that affects its acceptance, performance, and deployment? Can you elaborate a little bit? I think you already touched all of those things, but it will be nice to hear from you again, because this is critical. How do we deploy it? How to get it accepted in the market, Like, what are your,
Definitely.
yeah.
Yeah, so I think, we definitely have, obviously, you can tell, standards is definitely a place to start, but, Terry mentioned a couple items in terms of some of the practical, really once you start wanting to go down this route in terms of the design. And so, one of the first things is, when you're thinking about the design in terms of utilizing something like this, the climate is a big one. If you're in kind of a water-rich area, I grew up in Michigan, for example, which you can't go 6 miles without touching some kind of body of water in the state of Michigan. That's from my Michigan history class that I had taken 4th grade. Probably not going to be much of a use. You have lots of access to water. So I think right off bat, you're looking for climates like the desert Southwest, especially now in Arizona, where I live now. We're under an immense amount of water stress, including potential cuts to the Colorado River. As of this recording right now, we're looking at some pretty severe cuts to the Colorado River allocation that the Valley of the Sun is and other places in Arizona are supposed to receive. So, if there isn't water available, as humans, we can only survive 3 days without water. So we need to find another source for it. So I think that is definitely one of those climate constraints of things. But Terry mentioned water quality assurances. I would 100% agree. People don't want to get past that ick factor. We've talked about standards in the permitting process, making sure you're in compliance with local plumbing codes and any state health departments. I would also add though, energy consumption is a big one. Energy and water are definitely linked. And so finding ways to make these systems as energy efficient as possible. It costs a lot of energy to move water. I think in terms of I think it's a kilowatt per gallon of water in Arizona. We have some of the most expensive delivery from an energy standpoint.
Mhm.
And that has costs associated with it too. So looking at that energy, needed to create it, what does that do to your electrical power to your building? That's definitely a consideration that needs to be thought of here because if you're putting in essence, a whole nother, electrical service to produce water for your site, there's definitely, a trade-off there in terms of cost and benefit. So those are the kind of like real world things that we think about, on non-related topics to atmospheric water harvesting, but it's going to be the same paradigm that's used in the application when it comes to making a decision to utilize this on a project or not.
Mhm.
Yeah.
Well, and the standard that I was referencing before, they also have a section there where they do energy efficiency evaluations. And just to uh, put it in perspective, what Christoph said, the requirement on this is a minimum of 0.79 gallons per kilowatt. So that's a little more efficient than currently what's out there. So I think what's going to make this is there's more and more successes, and we advertise those successes. More and more people will be interested in it. I think as more and more people get interested in it, there's going to be more demand. More demand is going to, we're start seeing some economies of scale, and the price of these devices will probably come down as well. So it's really at the very threshold of being a well established technology, I think. But as it gets more and more established, the price is going to come down, the demand is going to go up, and it's the successes I think that's going to sell this more than anything else.
This is really a good information in terms of like the like what should be someone's target, in terms of energy, like how much energy per meter cube of water they need to achieve. That could be a good standard for them to get, in terms of energy, water production, and water quality. These are all very critical for this new technology to survive in the market, and this type of information to bring would be something would be great for this community, who are working on atmospheric water harvesting. So with that one, I would move to Amin. Amin has some question regarding some process focused questions.
Yeah, this section is standards development and certification. I have a lot of critical questions here for you. And the first one, what is the name of AWH standard? And how does an AWH standard generally cover? And what does it not cover?
Okay, so the standard that I've been referencing today is the ASSC 1090 standard, and that is for drinking water atmospheric generating systems. And so it's very specific to residential and commercial use. There aren't any size restrictions on it, but so far most of the applications that I've seen use the standard are smaller type devices.
Mm.
Now, when I say small, they're still like the size of a car. So, I mean, put that in perspective, small compared to some of the other systems that generate water, they're small. Um, there are, I believe, and I don't know the exact number, but I believe there are some electrical standards that UL has written around the electrical safety of these devices. And there are more and more developing all the time. We've had some interest in expanding the standard itself to include mobile units. So right now the standard covers units that are stationary. One of the applications that we had an inquiry about was, could this thing be used with an RV? So that while you're driving your RV around the Southwest or wherever you're driving it, doesn't really matter. It could be filling your potable water tank, and you wouldn't have to connect as often. So there's some kind of unique applications that we've had some inquiries on. So I think there'll be more and more standards as we get this technology to be a little bit more advanced and a little more accepted. So right now, IAPMO only has one standard. We've had a couple inquiries about expanding it, but we're kind of at that point right now.
Is it related to the atmospheric water harvesting? Like you said, like you have one standard.
The title is Performance Requirements for Drinking Water Atmospheric Water Generators.
Okay.
So it's specifically for water that's being used for drinking potable water. So
Awesome.
it's a type of water harvesting. Yeah, it's very specific in its application.
Awesome. Standards development is often a complex process involving many stakeholders. And
Yes.
so I have two follow-up questions here for you. How is a standard development and maintained? And the second one, what does certification typically verify? And what should reviewers look for in documentation and test reports?
Okay. So the standards development process, you're right, it's a very long process. Generally, we will start by press release and reaching out to people that we know who are stakeholders in the industry or the standard that we are developing. And so we get we call it a working group or a technical subcommittee. It's a committee of experts. And we just start hashing out all the requirements that we believe are necessary for a product. And we go back and forth. There's a lot of debate. There's revisions. There's some research. We look for reference sources that may help support that. We look for other similar standards that may have an aspect that's important for this standard. So that can take several months, or sometimes it can take years, depending on the complexity and how agreeable the technical committee is with each other. So, and once we get a draft standard, then it goes to our consensus body, which is another group of experts, and it's a second set of eyes, and they review it and they vote on it and they determine whether or not it should go forward. The standard also will go out for a public review. So in the US, it's a 45-day public review. So the public has 45 days to comment on it. And along this whole process, whether it's in the technical subcommittee, the consensus body, or the public review, any comments we receive have to be addressed. So make sure so by the end of the day, it's what ANSI calls a consensus process. Everybody's had their say. Everybody's been able to be represented. So for example, on our consensus body, we have different categories of people. So we want to make sure that it's balanced. We don't want all of one category or a category to have dominance over the committee. So, for example, we don't want all manufacturers on that committee. We want no more than a third manufacturers. Then we'll have regulators and consumers and maybe test agencies and a lot of other stakeholders that are also involved in this process. So that's kind of the way it goes. So to develop a standard from scratch is about a year to 2 years on the best case. And we've had some that's taken several years. And the second part of that was certification. So what certification does, which is separate from the standards development, it's a separate entity at IAPMO. The two aren't, there's a firewall between us for obvious reasons. But what the certification does is it'll say, okay, someone wants their product to be certified. You're going to certify it to the standard. So what they'll do is it'll go to a test agency, a test lab, and it'll be tested to the requirements of the standard. And then the test lab will generate a report showing that the product is compliant to all the requirements. Then that would go to the certification body. The certification body reviews the test reports. They also do things like dimensional reviews. So the standard may have some dimensional reviews in there. They may have some general requirements have to do more with design than performance, and they'll evaluate all that. Once the certification body has all the information that it feels comfortable that the product is compliant to the standard in its entirety, then they'll put a listing on their website saying this product is listed to the standard. And they also authorize that product manufacturer to put a certification mark on the product that shows that it's certified. So and then usually that certification mark you'll find in their literature, you'll find it in their marketing. But that's in the case of IAPMO, it's the IAPMO UPC shield. That tells you this product's been evaluated to the standard and meets the requirements of the code. And so that's what the consumer should be looking for. That's generally what regulators are looking for when they have products brought in. It's like, okay, it's been evaluated to a standard and it's been confirmed and is being backed up by this certification body. And then part of certification also is that once you're certified, you're going to be audited every year to make sure that your facilities and your production processes are sound and that you're not making you know, bad product. And then once every 5 years, your product gets retested to make sure that you're continually to comply. So it's a very, very detailed process. I don't think people really understand or appreciate how much goes behind the whole process from the developing of the standard to the certification and to the continuous compliance activities. So there's a lot going on there.
Christoph, do you have anything to add here? If not, I have one more follow-up question here.
No, Terry did a great job covering it.
Yeah, great job. Awesome. How can standards support innovation while still ensure safety, performance, and transparency?
Well, like I say, we have the stakeholders, and the general stakeholders are people who want the standard to be successful and do the right thing. So there's a lot of really good people that dedicate themselves to doing just that, writing standards, making sure they're good standards, making sure they're safe. Uh, the whole process is transparent. Like I said, there's a public review process. We have the consensus bodies meet once or twice a year. Those are open meetings. Anybody could attend to those. Uh, so the process for writing the standard is transparent in that way. Uh, Anybody can be part of the process. Uh, People can send an application, say, I want to be on this consensus body, and their application will be given consideration. There are some constraints, like I mentioned, there's balance. So if I had a manufacturer that says, I want to be on your committee, we'd have to say, well, I'm sorry, we already have our limit of manufacturers. You can be an observer. You'll get the information that the committee is working on, but you can't vote.
Oh.
But it's still open to those people. And we try not to get our committees too large. That's the other constraint that we try to put on ourselves. Uh, a good size seems to be right around 20, give or take a few. I've had a committee that was 75. That was really hard to keep people on task and keep people doing what they're supposed to be doing. And it gets become a little bit too unruly when it gets too large. So we try to keep them at a reasonable size, but they're open to everybody.
Now let's talk about how a standard influence engineering practice. I hand it over to Shahnawaz.
So I have now a lot of appreciation for your 40 years of experiences in this area. You're bringing so much knowledge to us, like how standards and certifications are critical, even for innovation. So thank you.
No problem.
And then I have got few more. So today we are talking about and emphasizing the importance of having atmospheric water harvesting related standards that we have emphasized. So my question to Christoph is how do you think having this standard can influence broader acceptance of the atmospheric water harvesting, and what we need to have in place for its evaluation and consistent reliability of this system?
So I would say, the broader acceptance by standards is, we've talked kind of about, the engineering process. We've talked about how the market would respond, but one of the things I can also say is that standards really provide one of the most key things with any new technology, and that's education opportunity. When you look at the engineering industry as a whole, whether it's engineering licensure or certifications to maintain a credential, one of the things that really becomes apparent is that there's a lot of hours every single one of the plumbing design professionals will almost invariably need to take in a given year to maintain those credentials. And there's some specific rules around that, which is the education sessions have to be non-proprietary. And so that becomes a bit challenging when you have a new technology, right? Because you want to talk about it, but there's not a way to do that to entice engineering professionals to attend those, because they're looking for some kind of continuing education to maintain a credential. So, really that being able to reference a standard and say, hey, I'm not going to come here and try to necessarily sell you on my product. I'm going to come in here and teach you about a standard. That is accepted because standards, IAPMO, we're a nonprofit, and like other nonprofits that do credentialing and that create standards that are out there in the construction industry. There's a certain acceptance by all professional development hour and continuing education unit, so PDH and CEU providers, and credential maintainers that when you have a session on a code or standard, that is okay. And that's a great vehicle to not only getting the general topic in front of new audiences, but doing so in a way that is more about providing education as opposed to just straight selling a product, which some people can respond negatively to. So that's really the standards, just by having manufacturers teach around those standards as well, it really helps drive adoption because it's no longer a conversation about, hey, buy this thing from me. It's more about, hey, here's this technology and here's what industry has come up with as a way to safely deploy these. And that education is vital. Again, it just really helps deliver value in multiple ways and really drives engagement and familiarity with new technologies.
Oh, I totally agree. Yeah.
Could I interject? Because he brought up something that was very important in the standard development that I think I missed,
Yeah.
is that when we develop these standards, we develop them so that they're not specific to any one product or one design. And so that it's not only important, it's a requirement from our accreditors that we write standards so they're generic enough that anybody who has a device that meets the scope can comply to the standard. So I think that's an important part of that development that goes with transparency is we're making sure that it's not just written for one manufacturer, one type of design. It has to be generic enough that it covers everything.
So the next question that I have is like, it's on more on the procurement side, when standards are incorporated and referenced in procurement, and how having this specification or the code can really help the engineers, inspector or owner, having those type of standards in front of them.
Yeah, so I can tell you from personal experience, really, the design that process, in terms of the drawings and the specifications, the like the book specifications, that's where we'd often reference different standards out there, and really by having them referenced in the construction process, whether it's in a code or in an engineering specification, it streamlines the process. From just speaking from personal experience again, when regardless of the technology, when I had a standard that I could reference that was in my specifications or was in the codes, it was one that I could look and on what was being provided and just confirm that it matched up with what was in my specification. It was a very quick way for the contractor who was submitting the equipment to me for my shop drawing review to build trust, because it was going along with what I had specifically indicated. And it also helped, ease any concerns of risk because I had already designed around a technology that could meet that standard. So what I would say is probably the biggest change is when standards are utilized in that procurement process, especially in specifications, it really actually streamlines the process. It makes it go faster, sometimes more noticeable than others, but it really will help streamline the ability to get the equipment in once it's been already made part of the design.
I'm going a little bit tangent to that. Do you guys already have this type of performance standard already built for atmospheric water harvesting in terms of equipment performance and in terms of the water quality performance? Is it something that you guys are working on, or is it already there for us to look at?
It's already there. I think that's the ASSE 1090 that Terry was mentioning.
The 1090 is there.
Okay.
For the water quality, NSF has a whole battery of water quality depending on how they're achieving that is also referenced in the IAPMO standard to make sure that if you're using, say, a filtration device, a particle filtration device, you're going to go to the particle filtration standard for NSF and make sure that you're compliant with that. So there are already some standards for the water quality. I think we're going to be expanding this for larger sizes and maybe some other applications. like I say, it's such a new technology.
Yeah.
We get inquiries. Some of them pan out, some of them don't. Some of them are a little premature, I think. But I think that as this becomes more and more prevalent, I think you're going to see more and more standards.
Great information. One question for Christoph. So how should engineers be referencing the atmospheric water harvesting standard in their specification to make the atmospheric water harvester requirement clear and enforceable? And what will you consider good versus red flag? I mean, you already touched on all of this, but if you just could share like a one or what are the good things and what are the red flags, like we need to avoid?
Definitely. So from the engineering standpoint, when I wrote and created master specifications for the organizations that I had worked for prior to my time with IAPMO, it was pretty easy to just go in and in this case, this particular technology might be part of a 22,000 specification on water supply, distribution equipment, and piping. It may be its own specification. An engineer may want to consider writing a completely standalone specification around this equipment. But regardless of which specification it's located in, it'll be critical to just make the note. The system shall comply with ASSE 1090. And whatever the latest version is. I think Terry, what are we on right now? Is it 2023?
It's 2020 reaffirmed in 2024.
2024. Okay. So just making sure you have the right years. That's always a good one to put in there. And just having that part in there. And then if you're having to write something from scratch, here's the beauty of standards. It's very doable for an engineer to go into the standard, either purchase a copy of it or to view it for free on our website and utilize some of the language in your specification. A lot of engineers will do that for med gas testing or other things. They'll go straight to the codes and standards and just point to certain things that are in the standard. A lot of the thought and expertise is already embedded in the standard. And even if the specifications haven't caught up, it's a great tool for really, utilizing, industry expertise that's already been out there to really making sure that those things like we talked about in terms of, water quality parameters or energy efficiency, those are great things that you can reference, alongside with that overall reference to 1090. But a lot of it's going to be covered already just by that simple reference. But then you can be a bit more specific of what things you're really going to look for. So that's on the specification side. And to answer your second question, Shanawaz, is, how do you enforce it? That's the shop drawing portion. At some point that project gets bid by an installer and they're going to provide shop drawings on the equipment they plan on purchasing. And if you have those requirements in the specification, it makes it really easy for the installer to say, hey, here's the stuff that we need to comply with. If they don't comply with ASSE 9 or 1090, we're not going to even bother with you. So it makes their process a lot easier. They can winnow out who shouldn't be in there. And when they submit something, then for the engineer, it goes back to, hey, I'm looking at two things that are, it's apples to apples comparison. Okay, this one's easy. Oh, this one has not some of these things that I'm looking for, and it doesn't have that certification, that compliance with the standard, and it's not listed to that. Well, then I'm not going to use it. And so everything goes a lot faster on that back end.
Wow, these are very important points. Yeah. I think, you have something to talk about the future of atmospheric water harvesting, some gaps area where Terry and Christopher can help us. Yeah.
Yeah. Thank you both. You put a lot of effort in this field.
Yeah.
And as a researcher in atmospheric water harvesting, I appreciate it. And right now I would like to ask about the future of responsible AWH deployment. What can an AWH manufacturer to do responsibly accelerate utilization in the future?
I guess I can take a first shot at it, Terry, if you're okay with that. What I would say right off bat is get involved. Get involved in our codes and standards process. As Terry mentioned, there's a number of inquiries for the 1090 program and looking at additional requirements or at other larger product standards. I would say just getting involved in that is one of the best ways to help that acceleration. And then once that's and that's in the standard, but also getting it into different codes, getting it into the Uniform Plumbing Code, getting it involved into the WESTAN, which is our Water Efficiency Sanitation Standard, coming up with getting involved in those arenas, because that's going to drive it in addition to any direct sales, business to business sales opportunities that are out there. Terry, anything else you would want recommend that I didn't
I
cover.
think that's important. First we have to have the standard, and once we have the standard, then the enforcement is we got to get people who write codes to recognize that this is what we need.
Mm.
And so getting involved in developing the standards and then helping with the process of getting them into the codes. Because once it's in the codes tend to drive demand. So now if I'm in a jurisdiction that this is in the code, I have no choice. I have to have a certified product.
Mm.
And therefore I'm guaranteeing that, or the idea is you're guaranteeing this product's going to meet the minimum requirements and meet the safety performance requirements. And that's the whole purpose of why we put these things in the codes in the first place, is to make sure that we have good, safe product in the market.
Yeah, sounds perfect. Shahnawaz, do you have any final questions here?
Yeah, I think I have one. Probably you have another one. So as a closing, I think you already have already told us like significance, the importance of this standards and how critical they are. And so my question may be a little bit of a repeat, but I will still go ahead and ask you this question. What advice would you give an entrepreneur or a new startup or a researcher very much interested in atmospheric water harvesting and why they should be engaging with the standard early toward making the performance claim properly? You've already covered it, but one or two sentences, if you both could share, re-emphasize, why it's so critical, that would be great.
Okay.
All this.
Well, I have examples, not necessarily for this market, but other examples for other standards where we've had people that have invested in developing a product, they've invested in manufacturing, and they're down at the 11th hour and they go, oh, wait a minute, what do you mean I have to do this?
Wow. Yeah.
And it's like, well, yeah, that's the requirement. Well, my product doesn't meet that requirement. It's like, well, that's why you should have been looking at the very beginning. What are the requirements? What is the market and it's not necessarily what the standard requires. You should also be looking at what is the market expectations for your product, because you should be managing expectations as well as the requirements.
Very
And so
critical.
I think it's really important that if you're going to start in this field, you need to understand what are the requirements, and what the expectations are, and I would say, where they're being used, how they're being used, because that all figures into your design and your processes.
Definitely. Yeah, and I guess kind of again, I think mirroring what Terry said, I think, I would the advice I would give is, if you really want to position yourself as a reputable manufacturer of this equipment, there's really no reason not to go the standards route. There's always going to be competition that may try to undercut you on price by making perhaps subpar performing equipment out there. It happens in every technology. And in this case, having a standard to fall back on makes sure that that everyone is playing by a fair playing field, and not undercutting or giving a bad name to new equipment, which I've seen happen too. So I would say, especially for somebody that wants to be leading in this area, having a standard makes sure that competitors don't sully the name potentially of new technologies, because that is very possible too.
So the standards could be like more like a guidelines or a path for entrepreneur to take the journey, and to see if they could make the standard or if they could even go beyond the standard. That would be
Yes.
a good way of
Yes.
looking.
Yeah, and again, to Terry's point, what you just said, Shanawaz, it's a minimum requirement. So if you go beyond and you're better than the standard, perfect. And that's a whole. But at least now you're on a more level playing field than if there is no standard and you have a competitor that isn't meeting the water quality requirements, let's say. And that was a cost cutting measure perhaps that they did. That would be pretty frustrating, especially if you spent time and effort into making something that really goes above and beyond.
Great. Sure. Now I have a lot of appreciation for the standards, like how critical, how important it is. I think Amin has a question.
Yeah, I have a question here. If you had unlimited resources, what would you fund to accelerate responsible adaptation of AWH, multi-climate validation site, long-term performance monitoring? Which part?
I think the best thing that they could do, and I don't want to say marketing, but get the message out.
Mm.
Here's our successes. Here's where it's working. Make people aware these are out there and that they're doing good things. I think that that's where this industry, I think, is probably a little behind, is not that many people know about it. I mean, it's almost a niche market still. I think if I had lots of money, I would be out there, not marketing it to sell my product, but marketing to get acceptance of this industry, this technology. And maybe I know it's new, but maybe there's an opportunity now for maybe them to have some kind of a trade association within manufacturers so they could all work together to promote the industry as a whole.
That's a great suggestion, Terry. And I would say, yeah, just to kind of add to that, piggyback on it, from personal experience, if we had a manufacturer of a certain equipment come in and show us that, their one case study that they had, it's like, great, sure, it's a case study, it's a data point, but I want to see a lot more data points. So if you start getting 100 data points of successful applications of these, and you have, to Terry's point, you have some kind of industry affiliation or industry push behind it, multiple manufacturers. That says a lot more than just one manufacturer coming into an office asking me to specify their product on a project, or asking an engineer to specify a product on a project. So I would say that definitely that speaks a different kind of volume, but it does take a lot of money. It does take a lot of time. So as we know.
Yeah, and it should be targeted. Target where your product's going to be used. Target where you think the people are most going to be accepting of your technology. So I
Awesome.
know we said unlimited funds, so I guess that's not that important. But even with unlimited
Yeah,
funds, I think you'd want to focus on where it's going to get the most bang for your money.
I would agree.
I agree also. Thank you both for sharing your knowledge and expertise and experience. And this has been a very informative discussion about atmospheric water harvesting standards and the future of responsible deployment. And thank you, Shahnawaz, for helping. And thank you to our listeners for joining us today. We hope this conversation helps researchers, engineers, innovators better understand the role of standards in advancing AWH. And thank you for listening, and we look forward to seeing how this field continues in development. Thank you very much. I really appreciate it.
Thank you, Terry. Thank you, Christopher.
Thank you. Thanks.
Thanks, both.
Thanks, everyone.
Have a great day.
You
Thank
too.
you.